So this exercise is related to how we can measure the mass, weight and density. In the first question, a cup contains hot liquid. Some of the liquid evaporates. What happened to mass and what happened to weight of the liquid in the cup? Use the screen annotation to state the answer. So you have a container which is filled with a hot liquid and some of the liquid evaporates. This is at the start, beginning, and this is after some time. The question is what happened to the mass and the weight of the liquid in the cup? You can use screen annotation or you can use a chat to state the answer. Yeah, that's right. A is the right answer because the number of the molecules in the beginning are more as compared to as the evaporation occur. The molecules will leave the liquid. So molecules which are left behind, they will have low energy as well as few molecules are there. That's why the mass decrease, and if the mass decrease, the weight will also decrease. In question 2, a piece of steel is taken from Earth to the moon for an experiment. The gravitational field strength on the moon is smaller than on the Earth. Which statement about the piece of steel is correct? A, B, C or D? Yeah, that's right. C is the right answer because what happened as a gravitational force or weight, we know W is equals to mg. So as the value of the gravity decrease, the weight will also decrease. That's correct. C is the right answer. In question 3, an object always has mass but does not always have weight. So object may have mass but maybe it does not have any weight. What must be present and acting on the mass to have the weight? So there should be a gravitational force or a gravitational field because without the gravity the weight will not be there. The object may have mass but the weight might be zero. Why? Because we have the formula W is equals to mg. So if the gravity is zero, for example object mass is 20 kg, but if the gravity is zero, the value of the gravity, then what will be the weight? The weight will be 0 Newton. In question 4, a spaceship approaches the earth from deep space. So it is coming to the earth from the deep space. Near the earth, a force on the spaceship causes it to have a weight. This causes it to change its speed and direction. Which type of forces cause the spaceship weight, and which property of a spaceship resists the change in the speed and direction? So because of the gravitational field, it will have a weight. Gravity will pull, so it will have weight. And why it will resist the change in state? We call that inertia, and inertia depends on the mass. So greater the mass of an object, greater the tendency to resist the change in state. So A is the right answer. Question 5. Diagram 1 shows a piece of foam rubber that contains many pockets of air. Keep in mind mass of air is negligible, can be neglected. The diagram 2 shows same piece of foam after it has been compressed, so the volume decreases. What happened to the mass and the weight of the foam rubber when it is compressed. So because we are considering air is not having a considerable mass or negligible mass is there for air. So even though some of the air will escape, but that is does not cause too much change in the mass. So D is the right answer. In question 6, a student wishes to determine the density of irregular shaped stone. First, he find the mass of a stone. Next, he lowered the stone into a measuring cylinder. The diagram shows a measuring cylinder before and after the stone is lowered. How should the student calculate the density? So to calculate the density, we need mass and we need volume. Mass student already measured. How he'll get the volume of the stone? So volume of the stone, if we subtract reading 2 from reading 1, so V2 minus V1, that will give us the volume of stone. So reading 2 minus reading 1 and mass of a stone divided by volume will get the density. Because density is mass divided by volume, here in option B it is written multiplied and option D it is written divided. So that's why D is the right answer. The diagram shows dimension and masses of 4 regular solids. The objects are made of different metals. Which metal is having the greatest density? To get the density, mass divided by volume. So what is the volume of this? It will be 2 multiplied by 2 multiplied by 1. So this volume will be 4. Volume of this 1 multiplied by 1 multiplied by 1. So it will be 1. Volume of this 1 into 1 into 2. So it will be 2. And the last one, volume will be 2 into 2 into 2. 2 multiplied by 2, 4. 4 multiplied by 2, 8. So this is it. How to get the density? Mass over volume. So this will be 20. The mass is 20 divided by 4. So that's equal to 5 gram per centimeter cube. What about this one? It will be 6 divided by 1. So it will be 6 gram per centimeter cube. What about this one? Mass is 14 divided by 2. So this will be 7 gram per cm cube. And the last one, it is 32 divided by 8, because the volume is 2 into 2 into 2. So that's 8. Total will be 4 gram per centimeter cube. So which is having the greatest density, A, B, C or D? So it will be C. In question 8, diagram 1 shows a measuring cylinder containing water. That's 30. Diagram 2 shows same measuring cylinder with 10 identical glass spheres, and that is 70. The mass of the one sphere is 10. What is the density? How to work out the density? When we subtract the two volumes, V2 minus V1, that will be 70 minus 30, which make 40 centimeter cube. But this 40 centimeter cube is the volume of 10 spheres. So volume of 10 sphere is equals to 40 cm cube. What will be the volume of one sphere? This will be 40 divided by 10. So the volume of one sphere will be 4 cm cube. The mass is 10. To get the density, mass over volume, the mass is 10 and the volume is 4. 10 divided by 4, it will be 2.5 gram per centimeter cube. So C will be the right answer. 4 cm cube is the volume of one sphere because there are 10 spheres, so we got the volume of one sphere. The total change in the volume, that is 40. So 40 cm cube is a volume for 10 sphere. We got the volume for one sphere, that is 4. But we need density, mass divided by volume. So mass is 10 and the volume is 4. So 10 divided by 4 will get 2.5 gram per centimeter cube. Hundred divided by, for no, actually you're getting a right answer, but you are not doing in a proper way. Is it? It should not be done in this manner, like 100 divided by, or you got the total mass basically. That's also a same way, Abdullah. If you got the, like, there's also another way. What you did, as you mentioned, that you got the volume for 10. So volume for 10 is 40, and this is a mass of 1. So you multiply it by 10, so you'll get the mass of the 10, that is 100. So total mass divided by total volume, you will also get 2.5. That is also a right way. So either total mass divided by total volume or individual mass divided by individual volume, you'll get the density. In question 9, the diagram shows a cuboid block made from metal of density 2.5 gram per centimeter cube. What is the mass? So how to get the mass? We should get the volume first. So it will be 2 multiplied by 2 multiplied by 10. So it will be 2 into 4 multiplied by 10, 40 cm cube. And we have the formula: density is mass over volume. Density is 2.5, mass is unknown, the volume is 40. This 40 is divided, other side it will be multiplied. So 2.5 multiplied by 40 will get the mass. That will come out 100 grams. Because if 40 is divided, other side it will be multiplied. Then the last question. The diagram shows an experiment to find the density of the liquid. What is the density of the liquid? So how to get the density of liquid? We need the mass of liquid. The mass of the container is 200 and mass of container plus liquid is 250. So what is the mass of the liquid? The mass of the liquid will be 50 grams. And what about the volume of the liquid? It is between 20 and 30, so it will be 25. So volume is 25 cm. To get the density, it's mass over volume. So 50 divided by 25, that's equal to 2 gram per centimeter cube. So B will be the right answer for this. Is it clear, question 10? Because 200 gram is the mass of empty cylinder and 250 is the mass of a cylinder with liquid. So when you subtract the two, you will get the mass of the liquid inside. So mass of the liquid is 50 and the volume of liquid is 25. So you will get 2 gram per centimeter cube. So this was a weekly homework exercise related to measuring mass, weight and density.